Okay, guys, rational numbers. And we've done this 1,000 times, but let's just talk about it for now. This small circle in here, hang on. This small circle says whole numbers. Whole numbers are 0, 1, 2, 3, dot, dot, dot. Those dots mean it goes on forever and ever. Okay? Now, this next circle, which includes all of the whole numbers, these are the integers. They're the whole numbers and their opposites, like -1, -2, dot, 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 forever in the direction to the left for the negatives. So integers are whole numbers plus their negatives, okay, or their opposites. Now, the last box that they show us today, the rational numbers, those numbers can be written as ratios. Alberto, yeah. What is a ratio?
It's a half.
It's not a half. What is a ratio, Rex? We call them something else. We see them all the time, and we use them a lot. But we don't call them ratios usually. We call them what, Will?
Numbers that don't have decimals?
No, because they can be written as decimals, that's for sure. Alex?
It's a percentage.
Nope. It's a fraction, gentlemen. A ratio is a fraction, a number over another number. Okay? Now, what they want us to do here is to show that all of these numbers can be written as fractions. All right? Leo, will you make that first one a fraction for me? Just tell me what to write. Thank you, sir. 7/1. Beautiful. All right. Taggart, will you make the next one a fraction for me?
Yes. -10/1.
Beautiful. Milan, will you make the next one a fraction for me? It's presently a mixed number, so we want to make it a fraction. We multiply 5 times 4 and we get 20. Yes. And then we add 3 and we get 23. So I'm going to write that down, but what? Over 4, the denominator that we started with. Okay? Beautiful. Thank you, Milan. Now, guys, I'm going to ask you to do something a little bit different on this last one. Miss HS may have told you to do this anyway. Okay? But whenever I have a negative mixed number, just forget for the moment that it's negative. And just think of it as positive, 3.5. And change that to a fraction. So it's 2 times 3 is 6, plus 1 is 7. So it's 7/2, but remember, guys, it was negative. So we're going to write it as -7/2. Now, someone may have mentioned this earlier. You may be thinking this right now. This could be -7/2. It could be -7/2. Or it could be 7/2. All of these three things are equal. The negative can be out front, on top, or on the bottom. We're going to make it our habit to write it on top. And the reason is because it helps us a lot with graphing. Later on, when we're doing some graphing of linear functions, it helps us with the slope, that kind of stuff. So we're going to make it our habit to put the negative sign on top. What we can't do is put it on top and bottom, because that's a negative over a negative, and it just makes it a positive, and that would be bad. Taggart.
But in that problem, you would do -3 times 2, and that would be -6, but then wouldn't you add 1?
See, -3.5. I want you to think about -3.5. You owe your friends $3.5, right? So -3.5. But if you do 2 times -3, that gives you -6. Plus 1, that gives you -5/2. Is that the same thing as -3.5?
Oh, no, it isn't.
That's -2.5. Because here's the reason, Taggart. This is really negative times 3.5. The 3 is negative and the half is negative. Both of them are negative, right? It doesn't say -3 plus and +1/2, right? This whole thing is negative. So we want to keep the negative out front, change it to a fraction, then we'll add the negative later. Okay? All right. Great job, guys. I'll see you at the next example before this thing cuts me off.